Picture this, a set of equations scribbled on a blackboard that end up predicting phenomena no human has ever witnessed. Within a few decades, telescopes or particle accelerators confirm those exact equations, as if the universe itself were following a meticulously coded script. This scenario isn't science fiction, it's the history of major physics breakthroughs. According to Dr. Max Tegmark of MIT, mathematics has a mysterious power to describe reality. But is the universe just playing along, or is it fundamentally mathematical at its core? In other words, are we living inside a realm governed by pure numbers, possibly akin to a vast computational code? To even pose this question shakes our assumptions about what's real. Because if math isn't just a tool, but the actual substrate of existence, then understanding numbers might be more akin to deciphering the source code of all that is. Stay with me, because over the next several minutes, we'll pull back the layers on the bizarre possibility that everything you see is a mathematical construct, and reveal why it might not be as far-fetched as it sounds. Throughout history, many mathematicians, including Pythagoras, Galileo, and more recently Roger Penrose, have hinted that numbers might be the foundational language of the cosmos. But what does that even mean? Take prime numbers, seemingly intangible, yet they govern cryptography and resonance patterns in quantum physics. Penrose, The Road to Reality, 2004. Or consider geometry. From spiral galaxies to DNA helices, geometric ratios recur in places that defy mere coincidence. This plunges us into a giant puzzle. If mathematics is just an invention, how can it so precisely predict physical phenomena we've never even tested experimentally? And if mathematics is discovered rather than invented, are we tapping into a cosmic blueprint? Modern scientists exploring the simulation hypothesis suggest that the laws of physics may simply be code. But is it actually code, or is it something deeper, more inherently mathematical? It's a mind-boggling intersection of philosophy, physics, and even computer science. Right now, you might think, what actual proofs do we have? That's exactly what we'll dig into next. The real data, why it could all be numbers under the hood, and how entire research fields have rallied around this possibility. Now, paradoxically, every time we think we've found nature's ultimate math-based structure, new observations push us deeper. For instance, constants like the fine structure constant or the cosmological constant are so finely tuned that even a minuscule deviation would render life impossible. Weinberg, Physical Review Letters, 1987. This begs the question, are these constants simply plugged in to some cosmic code? Yet certain quantum experiments reveal behavior that defies our standard numerical frameworks. Take quantum entanglement. Einstein famously deemed it spooky action at a distance because it defies local realism. Even so, advanced formulations in quantum field theory rely on elaborate mathematical symmetries, like gauge fields and group theory, to predict bizarre phenomena with staggering accuracy. The contradictions? Our math keeps giving us infinities or singularities, as if we're hitting the edges of a coded system that's beyond our classical understanding. Is that evidence that the system is bigger and more intricate than our current equations, or that we're missing a deeper interpretive lens? By exposing these anomalies, we see that the deeper we dig, the more mathematics both enlightens and confuses us, and that tension might be the biggest clue yet. Let's pivot to our ancestors who stared at the night sky, carving star maps on cave walls. The Babylonians used base 60 to track celestial motions with mind-blowing accuracy. Centuries later, Isaac Newton formulated laws of motion with calculus, revealing that the orbits of planets and the fall of an apple abide by the same mathematics. It's easy to forget that these breakthroughs weren't inevitable. Humans uncovered refined patterns that were alarmingly consistent across scales. This historical perspective underscores that mathematics, from the vantage of humanity, has always looked like an external realm we somehow access rather than invent. That emotional anchor, recognizing we've repeated this pattern of discovery for millennia, hints at something universal. Even civilizations separated by oceans or time independently arrived at similar numeric structures. Whether it's geometry for land division in ancient Egypt or fractals in African indigenous designs, the same fundamental patterns re-emerge. The emotional weight of that revelation is tremendous. It sparks a feeling that we're connecting with something bigger than ourselves, something that's been quietly woven into the fabric of our day-to-day reality for thousands of years. Let's talk about concrete data. One of the strongest exhibits for a math-based universe is the predictive precision of physical models. Quantum electrodynamics, QED, has been tested and confirmed to 13 decimal places. Feynman, The Strange Theory of Light and Matter, 1985. Such accuracy is unprecedented in any other human-constructed discipline. If our universe were built on random chaos, it's difficult to see how predictive formulas could so precisely match reality. Another example is the Large Hadron Collider's experiments leading to the discovery of the Higgs boson in 2012, predicted by a mathematically derived standard model nearly 5 decades prior. Consider that. We invented a math-based hypothesis about a never-before-seen particle, and the universe agreed when we built an experiment costing billions of dollars to check. Statistically, that's an incredible alignment between the abstract realm of mathematics and physical reality. The deeper we go, the more it appears that these patterns aren't just approximations. They're exact in ways that would be improbable if math were merely a convenient tool. This vantage point compels us to wonder, if mathematics were stripped away, would the universe itself unravel? To bolster that point, consider computational physics, where simulations replicate complex phenomena like galaxy formation or protein folding, using purely mathematical algorithms. Amazingly, the emergent results match real-world observations with breathtaking fidelity. Stanford's Folding Home Project, 2000. In the realm of cosmology, simulations of early universe evolution rely on equations from general relativity and fluid dynamics, run on supercomputers. The resulting patterns of galactic distribution nearly mirror the sky we observe through telescopes. This consistency repeats at every scale, from the minuscule realm of subatomic particles to the vast tapestry of intergalactic space. Could that all be coincidence? Detractors argue we interpret data in ways that fit our equations, or that we keep refining the math to keep up with anomalies. But those refinements themselves are systematically pointing to deeper numeric symmetries and universal constants, not away from them. It seems that each time we refine our models, we uncover yet another hidden layer of numerical elegance. For some physicists, that's precisely why they suspect we haven't just invented mathematics, we've merely discovered it, unveiling the structural code that was always there. If the universe truly emerges from mathematics, the implications aren't just theoretical. Take biology. Certain growth patterns, like the Fibonacci sequence in sunflowers or nautilus shells, exhibit symmetries that might be explained by energy minimization principles at a fundamental level. Or information theory, where the idea of entropy crosses paths with black hole physics, suggesting the cosmos itself encodes information in ways reminiscent of computational processes. Bekenstein, Lettere al Nuovo Cimento, 1972. Meanwhile, cognitive science points to the possibility that our brains evolved to perceive these mathematical structures accurately, because it's adaptive to interpret a universe built by the rules of numbers. This synergy between diverse fields, cosmology, biology, information theory, paints an evolving picture that everything might be stitched together by a single unifying language, math. Still, many open questions remain. For instance, if there is a universal code, who or what wrote it, or is it just self-existing? And could future breakthroughs in artificial intelligence or quantum computing decode deeper layers of whatever that primal structure is? Our search is far from over, but glimpses of the bigger picture are forming. Here's your invitation. Reconsider each law of nature you've ever learned and ask yourself whether it's just describing reality or literally generating it. We see numbers everywhere, yet remain unsure if we created them or they were always out there, waiting to be discovered. The results of centuries of exploration suggest a powerful hypothesis. Mathematics not only predicts, but might constitute the reality we inhabit. If that possibility stirs something in you, then share your insights below. What do you think? Is the universe built on code, or is mathematics our best but incomplete map of an even deeper mystery? Continue this conversation with others. Dive into the writings of Tegmark, Penrose, and countless research papers bridging quantum physics and computational cosmology. Perhaps the greatest frontier lies in exploring whether we can harness these hidden numeric structures to push the boundaries of knowledge, life, and consciousness itself. Let's keep the dialogue vibrant, well-reasoned, and open to new perspectives. After all, if the universe is numbers, then you, me, and all that exists are part of an ever-evolving equation, one we're only just beginning to decode.